let's do a couple application problems. To start off, let's try to go backwards. Here I have a graph for you. I want you to come up with the equation for that graph. So we're still going to start with our table of amplitude, vertical shift, period, phase shift. And we're going to list where each of these things are. So the vertical shift is where the middle of the graph goes. So there's my orange dashed line. So it looks like my vertical shift was up 1/2. That's how far that orange line moved up. Now that I know where my center is, I can look at my amplitude, where the top and the bottom are. So it looks like up to the top is 1, 2 units, and down to the bottom is also 2 units. So our amplitude is up 2, down 2 from that vertical shift line. Next, let's do our phase shift. Our phase shift is where this starts. So it looks like our phase shift was left 1. Normally we start on the x-axis, now we're starting left 1. And finally our period, which is how long the wave is, looks like this wave goes from -1 up to 5, which makes it 6 long. So let's put all of these into our equation. Here's our equation. Now, first off, we know that this is a positive cosine shape because it has the positive cosine shape. So we've got a positive and a cosine. We know the amplitude is multiplying in front, so there's my amplitude. We know the vertical shift is adding or subtracting outside, so since it's up 1/2, we're going to add 1/2. I know my phase shift is adding or subtracting inside, so since it's left 1, it's going to be +1. And then finally, for my period, remember, this is the period, but inside the equation, I should be putting my frequency. So to convert between the two, we do 2 pi over. So 2 pi over the period gives me 2 pi 6, which simplifies to a frequency of pi-thirds. And there's my equation for this graph. Now, example 6b asks for a very interesting question. It says, what if I actually want this to be a sine graph instead of a cosine graph? Because we know that they're the same graph, one has just been shifted side to side. So basically what we're going to do here is we're going to shift this graph to make it start as a sine wave. So I'm going to keep this going to right there. And now I have my phase shift out to here. And my period is going to end right there, because that gives me my S sine shape. So this is a positive sine shape. I still got that positive sine shape right there. And you'll notice that through all of this, the vertical shift and the amplitude didn't change. So my vertical shift is still +1/2 and my amplitude is still up 2, down 2. You'll even notice that the period didn't change. How long this is, we're going from, here, let's figure out where this is going, down. This is going to be -2.5. So this is at an x value of -2.5. And I know that because each of these is 1.5 apart. So I go 1.5 to get to here, 1.5 to get to there, 1.5 to get to there. So -2.5. So I'm going from -2.5 up to 3.5. That is still a period of 6, which would be a frequency of pi-thirds. That didn't change. The only thing that has changed is my phase shift. I'm now starting at a different point. So this phase shift, instead of moving left 1 to take me to that starting point, I'm now moving left 2.5 to take me to that starting point. So the only thing that changed is our phase shift is now left 2.5 instead of 1, which means this is going to be plus 2.5 instead of plus 1. And if you take both of these equations and type them into Desmos, you should get the same exact wave. They're both the exact same wave, just we wrote one as a cosine with a cosine starting point and a cosine shape, and one as a sine with a sine starting point and a sine shape. And that is how we go backwards. So we take a graph and write it as our equations. Let's do another application problem. This one, we have a circle. It has a radius of 3 feet, and it's mounted with its center 4 feet off the ground. The point closest to the ground is labeled P, and we want to start by sketching a graph of the height above the ground as the circle is rotated. Now, we're going to specifically say rotated counterclockwise. So let's start here at P. So we're going to say P is our 0 radians. Now, I know normally we put 0 radians here, and then pi halves, 3 pi half, pi, 3 pi halves, and 2 pi. But we're going to start down here because that's the starting place on our circle. So if this is 0 radians and I am moving counterclockwise, this would become pi halves radians. This would be pi radians. This would be 3 pi halves. And all the way around, I would end at 2 pi. So I just changed where my starting point is. I know usually on circles we're used to starting here, but we're going to start down there because that's where our P starting point is. And I want to list the height at each of these points. So when I'm down here at P, how far off the ground am I? Well, if I know the radius is 3 feet, that means this is also going to be 3 feet. And if the center is 4 feet off the ground and the radius is 3 feet, that means right here I am going to be 1 foot off the ground. Now let's move to my next point at pi halves. I am now centered, so that's going to put me at 4 feet off the ground. Up here at pi, that's going to be 4 feet off the ground up to the center and 3 more feet up to the top. So that's going to put me 7 feet off the ground. Over here at 3 pi halves, we're back at 4 feet because we're centered. And then at 2 pi, we'll be back to 1 foot. So let's graph these. Down here, we'll have my x-axis. And up here, we'll have our height. So we're going to go up to 7. 1, 2, 3, 4, 5, 6, 7. And I'm going to graph these points. So at 0, I was 1 foot off the ground. At pi halves, I am 4 feet off the ground. At pi, I am 7 feet off the ground. At 3 pi halves, I was 4 feet off the ground. And at 2 pi, I was back down to 1 foot off the ground. So this is a graph of the heights on this wheel as we turn around the wheel. So now let's take this graph and come up with an equation for this graph, just like we did in the last problem. So first off, our amplitude is, or sorry, not our amplitude, our vertical shift is our center. So it looks like this graph is centered at 4. So our vertical shift is up 4. The amplitude to get up to the top of the wave and the bottom of the wave, we went up 3 and down 3 to get to the top and bottom. So that makes our amplitude 3. This is going to be a negative cosine shape, which means our phase shift is right here at the beginning, so phase shift is none. And our period, how long the wave is 2 pi long. So I want you to take all that information and write a cosine equation. Cosine, because we know this is a cosine shape. And in fact, let's actually change this. We know this is a negative cosine shape. So pause the video, take all of this information, put it into the right place in the equation, and then come back to check your work and see how you did. Let's see how you did. So our amplitude goes first, period is multiplying inside, there's no phase shift, so I just did plus 0. Vertical shift is up 4, and if I simplify all of that, I get this equation. So this is the equation that models the height of where you are on this circle based on different angle rotations. Now I do want you to notice a couple things about this equation before we move on to example 8. First off, I want you to notice that 3, the amplitude, let's use better arrows. That amplitude is also the radius of this circle. That is not a coincidence. So that radius of the circle turns into our amplitude. Second thing I want you to notice is that plus 4, that is how the vertical shift, I should say, that is how far the center is off the ground. That's what makes up my vertical shift. So those two numbers have a direct correlation to a piece of this circle. The amplitude is the radius. The vertical shift is how far the center is off the ground. The reason I'm making a big deal about those is that's going to help us for example 8. In example 8, we're looking at the London Eye, which is a massive Ferris wheel in London. So I have my Ferris wheel here. It's kind of a wonky circle. Let me try one more time. That's better. And this Ferris wheel is off the ground. And it's got a bunch of fun little spikes on our Ferris wheel. So you can go around the Ferris wheel. This Ferris wheel has a diameter of 135 meters. Now the diameter, as we noticed in the last problem, isn't as helpful as the radius. So I'm going to cut 135 in half and say the radius is 67.5 meters. Now we know it completes one revolution every 30 minutes. And we'll talk about what that impacts in the equation in just a second. And we know that riders board a platform that is 2 meters above the ground. So here's the platform that riders board. It is 2 meters above the ground. We want to express a rider's height above ground as a function of time in minutes. So we have amplitude, vertical shift, period, and phase shift. And then we're going to turn all of that into an equation. So like we noticed last time, the amplitude is the same thing as the radius, which in this case is 67.5. We also noticed that the vertical shift is how far the center is off the ground. So 67.5 plus 2 gives me a vertical shift of up 69.5. Now, phase shift, we will have none because we get to pick our starting point. So we're going to pick our starting point to be right there. Last thing we need is the period. Now, the period is how long it takes to do one revolution. So if one revolution is 2 pi, it takes us 30 minutes to do that one revolution. That simplifies 2 pi 15ths. And that is actually our frequency. I should reword that. That is how many waves we can do in 2 pi. So in pi 15ths, that's how long we can do 2 waves. So we're going to say our height on this Ferris wheel is, we're going to do a negative cosine, just like we did with the last problem. And we're going to plug them all in. So I have my amplitude, my vertical shift, my frequency, and my phase shift. And that gives me an equation for the height, how far I am off the ground at any single point on this Ferris wheel. So that was a couple different application problems using everything we've learned about graphing. You are officially done with lesson 2.1 and you can get started on your homework.